You are following this book, right?
Yes.
Okay, here the first chapter contains so many concepts, binary to decimal, logarithm, and a little bit complex number is also there, right?
Yeah.
Okay, I'll be discussing this topic. This is going to be there in your exam, right?
Um, Ma'am, I have logarithm. I don't.
Okay, this one is not there. This book you are following. This book.
Yes, ma'am.
Okay, can you tell me what is the syllabus which is there in your exam and which has been excluded from the. Yes,
Um,
Neha, are you following this book? This. Okay, so logarithm is there. Complex number is also there.
yeah, it's there.
Okay, so I'll be taking logarithm and complex number over here. Okay. Yes, Neha, this is extra class scheduled to cover these two topics. The first topic containing logarithm. I'm just scrolling down. Do you follow this book, Neha?
No,
No?
no.
Okay. Can you send the link of the book which you follow, Neha?
I don't have the link.
Online, do you use ebook?
No, I use
Okay.
the textbook, like
Okay.
hard copy.
So what's the name of the writer?
ML Agarwal.
Okay, ML Agrawal. Yes,
Yes,
Manvi,
ma'am.
you also follow the same.
Ma'am, I follow this one.
Okay, you follow this one. Both the books are having the syllabus same. Can you see numbers and quantification and numerical application? These two chapters are there in your syllabus, Neha.
Yes, ma'am.
Okay, so more or less the concept is same. Type of question will also be same. Okay, so let's do few questions from here. If I will be able to open that book, the e-version of the book in today's class, I'll be taking that one. Otherwise, I'm asking the team to just send me the book which I can take in the next class. So for now, let's continue from here. Yes, Neha, complex number is also there in the first chapter in your book.
No, ma'am.
This logarithm is there, right?
Yes, ma'am.
Do
Only
you know
logarithm.
property of logarithm? Yes, Manvi and Neha. Properties of logarithm.
Um, Ma'am, I had learned it, but then I kind of forgot.
Okay, you have learned it, but you cannot recall it. So let me write the properties first.
Ma'am,
Yeah.
are these classes revision for the exams or?
Yeah, this class has been scheduled for revision for the exam. This two chapters, is it there in your exam, Neha?
No,
No?
no, logarithm is not there for this exam.
Okay, logarithm is not there. Then what is there?
Numbers and quantification, then numerical application, clock time, work and distance,
In number and
sets.
quantification, what is there? Binary to decimal, decimal to binary, is it there?
Yes, ma'am.
Okay, and what else?
Uh, Sets, relations and functions, permutations and combinations, and then
Oh yeah,
limits.
sets we have done in our batch. You was there, Neha?
Yes, ma'am.
Yeah. So those chapters we have done over there. Today I'll be taking this one. Okay. If A little bit I'm giving you the overview of this one. I'll also take binary to decimal. It will be helpful for both of you. Okay. So
Okay.
logarithm, as you can see, the first logarithm of product, which says that if two m and n are multiplied together, which is along with the log like this, log base is b over here, and we are having log mn. If this way we are having, then we can do the addition. We can separate the log, we can take the same base, and we can take log m plus log, the base will remain same and it will be log n. Okay. So this is the first rule which you can see on the screen as well, which says that when product is there, we can write it in the added form by separating the log. Okay. Now there are few examples also given over here. For example, if you are having log of base 10 and you are having here 2 into 3, you can write it as a log, the base will remain 10 and it will be log 2 base 10 and log 3 base 10. This is how we'll be using the rule. Product is there, we can separate the log. Right, Manvi?
Yes, ma'am.
Okay, when division is there, when we are having log b, the base is b. Base can be anything. Okay, base is b over here, for example. And if we are having m divided by n, when multiplication was there, we were adding. When division is there, we will be doing the subtraction. That's the property of log, that we are having log, the base will remain b and we'll be having m, minus log, the base will remain b and we'll be having n. Okay, this is the rule, that just do the subtraction when division is there. Okay, you can see one example over here. 81 by 8 is there, log base is 3 and 81 by 8 is there. Since division is there, we can separate. We can write log 81 base is 3 minus log 8 base is 3. Okay, now we will try extending them more. We can write this 81 as a 3 to the power 4 like that. So 3, here we'll be having 3 to the power 4 and here we'll be having log 3. Okay, I mean the base is 3 and it will be 2 cube. Making sense? Yes, Manvi and Neha, to both of you, is it making sense?
Yes, ma'am.
Yes.
Okay, just give me a moment now. Yeah, and now we are going to use the next property of logarithm, which says that if we are having log, if whatever be the base is b, if we are having suppose a to the power, let's say m, then this power can come in front. We can write it as a m log a will remain as it is and the base will remain as it is. This is another property of logarithm. Making sense?
Yes, ma'am.
Okay, so that's what I'm going to do over here. The power 4 will come in front. We'll be having 4 log 3 base 3 minus there 2 cube is there. Power 3 will come in front and we'll be having log 2 base 3. Yes, Neha, this logarithm is not there in exam, but it is there in your book or it's not there?
It is there.
It is there. So yeah, that then it will make sense to you. I'm taking whatever is important for you one by one. I'm taking today's class is scheduled for 1.5 hours. We'll be able to cover everything, whatever is there in your syllabus and whatever is there in your syllabus, Manvi. Okay. Now the next property of logarithm. This is property number 3. Then property number 4 says that if the base, if you are having log a base a, the result will be 1. Okay, if you are having log 10 base 10, the result will be 1. So we can say if we are having log 3 base 3, the result is 1 and 4 multiplied with 1. Okay, there we cannot do anything. We have to leave it like this, like this. And this is how we have to leave the answer. Is it making sense? Is it making sense? Yes, Neha, are you getting it?
Yes, ma'am.
Okay, so you can clearly see the property number 3 when we can shift the power in front, and the property number 4 which says that if your base and the number with log, if that is matching, then the result will be 1 always. Okay, there are there are two types of log. One is natural log and one is, just a moment, let me show you the common log. Can you see this answer and our answer? This is what we have obtained, right? Right?
Yes.
Okay. So doesn't matter. Even if you are thinking that the first one is getting answered out, but why the second one is not getting? Okay. We want to just simplify the second one just like the first one, but there it is not possible. So it's completely okay to leave your answer as it is. Okay. Now change of base rule says that actually it is written over here in this format. I am showing you another format which will make sense to you. Just a moment. Suppose you are having log b and the, okay, the base is b and you are having a, and you want to change the base. Okay, this base b you don't want. I will give one example where you can use this property. So you can introduce a new base according to your choice. If you want to take the base as a 3 or maybe 4 or maybe 2 or maybe 5, you can take the base according to your choice. Okay, so suppose I want to take the base as a c, so I can write base is c and the this a, okay, which is originally with log, that I'll be writing as it is, and then in the denominator again log the base which you have decided that you want to change the base as a c, so this base c, and then you will be writing this b in the denominator, and this way you can change the base of the logarithm. This formula is written in question number 4. As you can see, I'm showing you why the different version is written. So see carefully over here. It's log, just a second, log base is b1 and n we are having with the log. Okay, suppose we want to change the base as a b2. So what we can write? Log b2. Okay, and this n I have to write in the numerator, and then in denominator log b2, and this b1 I have to write. Yes or no? Making sense? Are you
Yes.
getting it? You are writing this one in the numerator with your base, and you are writing this one in the denominator with your base. Yes, Manvi and Neha, are you understanding this property?
Yes, ma'am.
And when I will switch the side, see carefully, it is log b1n into log b2 b1, that is equals to log b2n. Can you see this formula is given to you, the multiplied version, but it is the same thing. Are you understanding it? for example, if I am having, let's say, let me take one example from here. Just a moment. Let me take one example where we can use this rule. See, if you have to find, suppose you have to find log, here the base is 8 and here you are having 500 and you have to find the value of this one. Okay, so this is one of the scenario where you can use the change of base rule. What you can say that if you will introduce the base as a 2, okay, maybe 2, okay, then maybe it will be easier to solve because this one will be able to simplify this one also. Let me show you. So if you will introduce the base as a 2 in the numerator and the base as a 2 in the denominator, now you have to copy paste the 500 will be there in the numerator and 8 will be there in the denominator. This was the property, yes or no? Yes or no?
Yes, ma'am.
Okay, now what you can do, the denominator is simplified. Can you see? You are able to get log, the base was 2 and the 8 can be written as 2 cube. Okay, this power will come in front. I'm just showing the denominator part for now and you will be having 3 log 2 base 2. The denominator is simplified, which means just 3 in the denominator multiplied with 1. Making sense? Making sense?
Yes, ma'am.
Yes, ma'am.
Okay, and now what about the numerator? So I said, okay, if we can do whatever simplification is possible, we'll be doing it. And if there will be a point where we cannot do anything, then we will leave our answer as it is. Okay, so we are having 2 to the power 500. We can do the factorization of 500 and we can see how can we write it. So it is 2 square into 125. It is log 2 square into 125. Okay, here you can use the product rule. If you are having log basis 2 square into 125, so you can separate the logs. You can say it will be log m plus log n, right? Log m plus log n, yes or no? Right, here also it is becoming, okay, this power will come in front and you'll end up having log 2 base 2, which is just 1, and that part you cannot simplify that much, so you can leave your answer as it is. Is it making sense? Is it making sense,
Yes, ma'am.
Neha and Manvi?
Yes,
Okay,
ma'am.
here we are having 3 4 questions related to logarithm where we'll be using all these properties. So first tell me, the change of base rule is clear to both of you? Is it clear,
Yes. Yes, ma'am.
Manvi? Okay, let's do these questions. we are having log b, and in numerator we are having a to the power a, b to the power b, over c to the power c, d to the power d. So you can take the numerator as a m and denominator as a n, and you can see, we can clearly see m divided by n format is there. That means log b m minus n, right? Right? Okay, our m is whatever we'll write it, and whatever is our n, we will write it. Making sense, Manvi?
Yes, ma'am.
Neha, are you getting it?
Yes, ma'am.
Okay, let's move. We'll write this a to the power a, b to the power b. Again, you can take it as a m into n type of format is there. So let's separate it by doing the addition, right? Because it says expand it. So we will be expanding as much as possible. Okay, I'll be writing log the base is b. It will be m plus n. Making sense? Similarly, over there also we'll be writing m plus n. But be careful, minus sign is there. Okay, you have to write your m plus n in the curly bracket. Making sense? Are you getting it, Manvi?
Yes, ma'am.
Okay, here you are going to take the power. Power will come in front. Okay, so a will come in front and you will end up having log a base b. Here also power will come in front and you'll be having b log b base b, which is just 1. Okay, log b base b is just 1. Okay, minus you are having log the base is b, and c to the power c you will be having. So this c will come in front and you will be having log c base b. That way you are just expanding it. Okay, meanwhile if any of the term will cancel out each other, great. And if not, fine. Okay, you will also be having over there log base b d to the power d. So you can say minus, that's why I have given the curly bracket. Okay, d will come in front and you will be having log d base b. Is it clear, Manvi and Neha?
Yes, ma'am.
Okay, here only one part is getting simplified, which I can see for now, this log b base b. Okay, that will be 1. So you will just left with b, this b, because this underlined part will be just 1, right? And you will be having log a base b. That's it. Okay, after that you there is no simplification which we can do, so we'll leave the answer as it is. And that way we are, what we have done over here, expanded it. Okay, we have just done the expansion. Is it clear? Is it clear,
Yes,
Neha
ma'am.
and Manvi? Similarly, one more
Yes, ma'am.
expansion is given to us, the part B. Same way we will be doing whatever simplification will be possible, we'll be doing it. And wherever we will feel that nothing is possible, we will leave it. For now, I can write directly the next step, or maybe the third, fourth step directly I am writing, and you tell me, are you understanding? This one can be written as log 4x to the power 6 will be, okay, base is b, 4, plus log base is b, x to the power 6, minus base is b, 9, minus, okay, due to that curly bracket, log base is b, y to the power 7. Making sense, Neha and Manvi?
Yes.
Now you can just shift the powers, the exponent in front, and I can clearly see no other simplification is possible. So we will be leaving our answer as it is, and we are done. That's called expansion. What are we doing? Expansion. Next part is talking about simplification. So here we will try writing it in compact form. Simplification means we will try writing it in compact form. If we are having log a base 10 plus log b square base 10 plus log c cube base 10, all the bases are same and all are just added together. That means it must have come from the product, right? The product rule. Yes or no? A into b square into c cube. Can I write it this way? You have just seen the rule for two terms, m plus n, or I mean, see, you have just seen the rule for this one, log m into n base b can be written as log m plus log n. But actually, this rule is applicable for any number of terms, okay? M into n into k also I can write over here, and this rule will get extended just like that. That log k base b, making sense? मेकिंग सेंस? जो तुमने
Yes.
दो टर्म्स के प्रोडक्ट के लिए रूल देखा है कि जब भी लॉग के साथ दो टर्म्स मल्टीप्लाइड होते हैं तो उन्हें हम एडिशन फॉर्मेट में लिख सकते हैं। मैं बोल रही हूँ ये सिर्फ दो टर्म के लिए नहीं, जितने भी नंबर ऑफ टर्म्स हो, 3 टर्म्स, 4 टर्म्स, 5 टर्म्स, 6 टर्म्स, हम सेम रूल को अप्लाई कर सकते हैं जब हम एडिशन की बात कर रहे हैं तब। आ रहा है समझ में?
Yes.
ओके, इसलिए हमने क्वेश्चन नंबर 3 में ध्यान से देखा, बहुत सारे टर्म्स आपस में एडेड है और सारे ही टर्म्स में लॉग का जो बेस है वो सेम है। तो हमने बेस लॉग बेस 10 को एक जगह फिक्स किया और उसके बाद ए बी स्क्वायर सी क्यूब तीनों को मल्टीप्लाई कर दिया। ऐसा करके हमने इसे कॉम्पैक्ट फॉर्म में लिखने की कोशिश की, जिसे हम सिंप्लीफाई भी कहते हैं। आ रहा है समझ में?
Yes.
ओके, ऐसे ही सॉल्व करते लॉग जब भी एक्सपैंड, whenever it says expand it then we will be expanding it, whenever it says simplify it that means we will be writing it in compact form just like this. That means we have done the addition and this is the answer. This is the answer, we are done with the addition. Okay, we can write it directly that the answer is log base 10 a b square c cube. This is the answer. Clear?
Yes.
ऐसे ही हम क्वेश्चन नंबर 4 को सॉल्व करेंगे। हमें क्या करना है? सिंप्लीफाई। ध्यान से देखो, हियर इज बेस ए, ओके, log a base a is 1, okay, here also can you see log a base a is 1 minus the power you can take in front and it will become log b base b. Is it readable, Manvi and Neha?
Yes.
The power you can take in front and it will be log c base c, and the power you can take in front and it will be log d base d. Okay, you can see it is much more simpler than the previous one. What you can do, log b base b will be just 1, so 2 into 1 is 2. Log c base c is just 1, so it will be just 3. Are you understanding why I am writing just 2, just 3 and just 4? Making sense?
Yes, ma'am.
Okay, अब हमें सिर्फ इन सारे नंबर्स को सिंप्लीफाई करके फाइनल रिजल्ट लिखना है, वही हमारा आंसर होगा। ठीक है, क्लियर?
Yes, ma'am.
So we are done with this part. One more part is there for logarithm. Yes, Manvi, this type of question is also there in your syllabus. This type, the let the population of the world in T years after 2010. This type of question.
No.
Word problem from logarithm. ऐसे वाले
No.
क्वेश्चन सिलेबस में नहीं है, राइट?
No, ma'am.
ओके, then today itself just revise these properties and solve all the exercise and example based question, Manvi, and let me know if you are having anywhere any confusion. Now I am going to take binary to decimal and decimal to binary, which is there in Neha's syllabus. Let me take it. So yes, Neha, in your first chapter, just binary to decimal is there in the syllabus and nothing else.
Yes.
Okay. So whenever we are talking about binary number, okay, first decimal number. Decimal number means if you understand all the number which we are having in hand, okay, when we are talking about the counting, all the counting number that is made up of this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, हमारे पास सिर्फ इतने ही डिजिट्स हैं. इन्हीं डिजिट्स को यूज करके हम जितने भी नंबर्स, ओके, 1 लाख, 1,000, 2,000, 14, 15,000, 24, we can make it by using these number only, right? राइट, हमारे पास जितने भी काउंटिंग नंबर्स हैं वो इन्हीं डिजिट से मिलके बने हैं. हाँ या
Ma'am,
ना?
I don't speak Hindi.
ओके, इसलिए जब भी हम डेसिमल की बात करते हैं, देन वी राइट 1.
Ma'am,
या
I don't speak Hindi.
ओके, यू डोंट अंडरस्टैंड हिंदी, राइट?
No.
Oh yeah, okay, I thought you know it. Just give me a moment. Sorry, I thought that you know Hindi. That's why I was explaining it in Hindi as well. So yeah, all the numbers which we know, okay, any counting number, those are just made up of these 10 digits, right, Neha?
Yes, ma'am.
That's why our decimal numbers base is 10. Have you observed the base decimal numbers base is 10, right?
Right.
Right. Okay, and uh, the computer, the PC, the software, the language of device is different than ours, and this device just use 0 and 1, okay, just two digits. That's why the base of the binary number, it's just 2, right? Now, today we'll be saying how to convert decimal to binary and binary to decimal. So here the first part is asking which of the following in decimal notation. Okay, which of the following is in decimal notation? Decimal. Okay, the base needs to be 10, right? Right? Okay, it doesn't say which, it says write the following number in decimal. Okay, so we have to convert this one in the decimal notation. From binary to decimal, we have to convert. I'm taking the first one. It is 10101011000110. Do you know, Neha, how to convert from binary to decimal?
Prime factorization.
Yeah,
Prime factorization.
prime factorization. No, see, we are going from binary to decimal.
Uh,
Okay, that is from decimal to binary. Here we will take, this is the 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, 10, this is 11, this is 12. So now I'll do the multiplication. Okay, the first one, the blue color first digit 1, that I'll multiply with 2 to the power 12, because that is 12th place. Is it making sense? Right? right, Neha?
Yes, ma'am.
Then the next digit 0 multiplied with 2 to the power 11. Basically from the this you can call it ones place, or from the last you have to count 0 1 2 3 4 5 6 7, whatever number till that you are going, and then accordingly you will take the power. So I have counted from the last 0 1 2 3 4 5 6 7 8 9 10 11 12. Now I'll write the first digit multiplied with 2 to the power 12, then the second digit multiplied with 2 to the power 11, then the third digit 1 multiplied with 2 to the power 10, then the fourth digit 0 multiplied with 2 to the power 9, then the fifth digit 1, all added together. Okay, all added together. Just like this. Can you see this one? The number is given in decimal notation. Uh, we are going to convert the given number in the decimal notation like this. See, we have counted. This is 0, this is 1, this is 2. The places I am counting. Okay, 0 place 1, 2, 3, 4, 5, 6, 7, 8, ninth place. Okay, so we are counting from, either you can do the multiplication from the starting or you can do from the back, it's the same thing. Okay, so what you can do, you can multiply this one. I am telling you to just do the calculation from the starting. Here it is given in different format. I am showing you what is given over here. Let me write my thing. 1 into 2 to the power 9, I am saying you that, right? Then I am telling you to take 2 0 into 2 to the power 8, right? Then I am telling you to take 1 into 2 to the power 7, right, Neha?
Yes, ma'am.
Is it making sense?
Yes, ma'am.
Then I'm taking 0 into 2 to the power 6. Then I'm taking this 1 into 2 to the power 5. Then 0 into 2 to the power 4. Then 1 into 2 to the power 3. Okay. Then 0 into 2 to the power 2. Then 1 into 2 to the power 1. And then 0 into 2 to the power 0. Okay. These are all the things I have written. And when you will do the calculation of all of this, you will end up getting 682. If you are wondering what is written over here, then see carefully, it is written from the back. First 0, then 1 into 2 to the power 1 from the back. Are you able to match it? Making sense, Neha?
Yes, ma'am.
If you are getting confused with this much huge number, let me show you with the smallest number. For example, you are having 11 and this is in let's say binary, and you are converting it in decimal. So you will say this is 0 place, this is 1 place. You will be multiplying the green color 1, the given digit, multiplied with 2 to the power 1, plus the next one multiplied with 2 to the power 0. When you will do the multiplication, you are going to get just 2 over here, and 2 to the power 0 is 1. So just 1 over here. That is 3. In binary, it is 11. Okay, 1, 1. And in decimal, it is 3. You can give the base as a 10. Making sense?
Yes, ma'am.
Okay, this is how all the numbers, see, be careful while converting from the binary to decimal. Okay, when we will be converting from decimal to binary, yeah, then we'll be doing prime factorization. Let's take one example from there as well. Actually, these concepts you must have learned in any other classes as well. But here only the thing is you will be getting such a huge number, and calculation may take time, and you should not overlook any digit while doing the just the calculation. Okay. Just a moment. Please do this question number 1 so that I can move ahead. Yes, Manvi and Neha, if you have understood, please do this one. First one. Can you see the first one? Yes, Neha, can you see the first one?
Yes, ma'am.
Yes, Manvi, you have also understood it, right?
Yes, ma'am.
Okay, try it. I'm taking the next concept. Are you done with this one? Yes, Neha and Manvi, are you done with this one?
No,
No, Neha, you are not able to do.
no, I'm still doing.
You are doing it.
Yes, ma'am.
Okay. Are you done, Neha? Yes.
Ma'am, which one?
Yeah, what is the answer?
I got 10,956.
Yes, Manvi, what you are getting?
I'm not sure how to do it.
Okay, this part is not there in your syllabus, right?
No.
Okay, you can leave it. Yes, Neha, that will be the answer. Okay, you must have done like this 2 into this 1, the first digit, multiplied with 2 to the power 12, added with 0 into 2 to the power 11, added with this 0, added with this 1 into 2 to the power 10. Have you done like this, Neha?
Yes, ma'am.
Yeah. Okay, let's move. These all the numbers we are supposed to write in the decimal notation. It is just expecting us to write the base as a 10. Okay, the base as a 10. We don't have to convert it. We don't have to do anything. We just have to take the base as a 10. Making sense? Yes, Neha, is it making sense?
Yes, ma'am.
Okay, simplify the following and write in decimal notation. So you will be converting it in, okay, decimal. You will be converting it in decimal, and you will be converting it in decimal. Now add them all. You will be having the answer in decimal. Clear? Clear?
Yes.
Okay, let's move. Yeah, here also the same way you can convert in decimal, the way you have learned previously in the first part. Now the last one is saying simplify and write in binary notation. So you can take this one. Okay, you can convert it in decimal. Then you can multiply this number with this number, which will be huge. Okay, and then you can just convert them back by doing prime factorization into binary. Making sense? For example, suppose I have given you, I'm showing you with a smaller number, which you can do later. Suppose I am telling you there is a number 11. Okay, here the base is 2. And we are having, suppose 24, I want to multiply with that. Just now we have converted 11 and we got 3, right? Right? 1 into 2 to the power 1 plus 1 into 2 to the power 0, right? So 3 into 24, that is 72. Decimal, you can convert it in binary. Making sense? 72, you can convert it in binary. How? By doing prime factorization. Are you getting it, Neha?
Yes.
Remainder I am writing. Do you understand these steps, Neha?
Yes. Yes.
2, 4 times 8, remainder will be 1. 2, 2 times 4, remainder will be 0. Okay, 2, 1 times 2, remainder will be 0. Right, Neha? Making
Yes.
sense? And you will be taking from backside to upside. Do you know how to convert this decimal number to binary number? Let me take one example properly. Suppose we are having 72. It is decimal made up of those 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It is in decimal. Yes or no? Right, Neha?
Yes. Yes.
And we want to convert it to binary. Okay, the base as a 2 and containing only digits 1 or 0. So we will be, okay, taking 2. Always we take 2, right? And we do the prime factorization. So 2, 3 times 6, 2, 6 times 12. Remainder, nothing, 0. Making sense? Making sense?
Yes.
Are you getting it, Neha?
Yes, ma'am.
Now 2, again, 2, 1 times 2, 2, 8 times 16. Remainder, nothing, 0. Now again 2, 9 times 18. What is left? Nothing. Remainder is 0. Then 2, 4 times 8. What is left? 1. Remainder is 1, right? Then again 2. 2 times 4. What is left? Nothing. Remainder is 0. Then again 2. 1 times 2. What is left? Nothing. Remainder is 0. Now you have to write it. We are done. Okay. Now you have to write it from downside to upside like this. And your answer will be 1, 0, 0, 1, 0, 0, 0. We have converted 72, which was in decimal. We have converted it to binary. Decimal to binary. Now, if you want to check the method which you have learned, okay, I will show you how to convert binary to decimal from this number only 1001000. Okay, I was telling you that you should count the place starting from 0. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. And you should take 2, okay? 1 multiplied with 2 to the power 6 plus 0 multiplied with 2 to the power 5 plus 0 multiplied with 2 to the power 4 plus 1 multiplied with 2 to the power 3. Wait. Yeah. 1 multiplied with 2 to the power 3. Okay. Plus 0 multiplied with 2 square plus 0 multiplied with 2 to the power 1 plus 0 multiplied with 2 to the power 0. Making sense, Neha?
Yes, ma'am.
I'm just showing you that, yeah, you will be getting 72 from here. Okay, 2 to the power 6 means 1 into 2 to the power 6. That means 2 to the power 6. 2 to the power 5 means 32. 32 2 times 64. So we'll be getting 64. This will be completely 0. This will be completely 0. This will be 2 to the power 3. 1 into 2 to the power 3 will be 8. This will be 0. This will be 0. This will be 0. Can you see we are getting 72? I have shown binary to decimal, decimal to binary. Is it making sense? Are you understanding, Neha?
Yes, ma'am.
Okay, so these two things are really important for you. Now, when the team is sending me the book, I'm taking these. I will see if any other things are there in your book. So, any confusion so far? Yes, Manvi, in your syllabus, complex number is also there, right?
Yes, ma'am.
Okay, permutation and combinations we are doing. September 29, you are having exam. Before that, I'll pick complex number in our batch itself because here you need proper understanding, which is there in our core math student syllabus as well. In your syllabus and in their syllabus, the portions is same. However, the questions in your syllabus are less and they are having more question, but the concept is same. They are also having modulus, they are also having conjugate. All the things are exactly same with core student. So I'll be taking this chapter properly over there. Okay. What else is there? We are done with this first chapter, right? Manvi and Neha. Yes, Manvi. Complex number, if I'll take over there, then we are done with first chapter, right?
Yes, ma'am.
And yes, Neha, what am I missing? If we are done with binary to decimal and decimal to binary, what else is there in the first chapter? Indices is,
Nothing else, ma'am.
yeah,
Nothing else.
nothing. Okay, so we are done with first chapter. Now let's see the second chapter. Numerical application. This chapter is there, right? Average is there in both of your syllabus, average chapter. Okay, average is there in this chapter 2, average. Can you see the first concept is average speed, average velocity, average is there. Have you done average in your school, Manvi and Neha?
No, ma'am.
No.
Both of you have not done average. Which part you have done? Can you tell me?
For numerical applications,
Yeah, from numerical application.
clock, time, work, and distance.
Okay, you have done clock, time. Both of you have done clock time. Yes, Manvi, you also.
It,
Okay.
yeah,
Neha, clock and time you are also having.
Yes, ma'am. Work and distance also.
Can you please repeat?
Work and distance also.
Work and distance. Yes, Manvi, you are also having work and distance.
yes, ma'am.
So today we can take work and distance since both this is common for both of you. Uh, Work done in order to. I think the last part. Let me check. This reasoning also, who is having this reasoning based question? Manvi, you or Neha, you? One day, who was telling me that you are having sitting arrangement and all of that, right? Right? No? Just a moment. Hmm. I'm sharing the screen. Yeah, I'm sharing the screen. Can you see the screen? Yes, Neha and Manvi, can you see the screen?
Yes, ma'am.
Okay, let's do it. See, if you will understand this type of question, that pipe A can fill a tank in 20 hours. Okay, pipe A can fill the tank in 20 hours. Completely, it is able to do the task in 20 hours. But due to leakage, it is taking thrice the time to fill the tank. Okay, so there is a leakage. Due to that leakage, it is taking thrice the time to fill the tank. Okay. How long will it take to drain out the tank if the pipe A is closed? So in such question, always we must start with the efficiency of A. What is actually the efficiency of A, right? Okay, let me take one question from the exercise, the basic one, then I'm coming to this type of question. So actually here it says Navya is twice as efficient as Niti. In such question, we need to understand the efficiency. Okay, I can write maybe 100 pages in a day and you can write maybe just 50 pages in a day. So your efficiency and my efficiency can be different. Agreeing with that?
Yes.
Okay, now it says that Navya is twice as efficient as Niti. Navya is twice as efficient as Niti. That means if a task is done by Navya, you need to understand this way. Navya is there, Niti is there. Navya is twice efficient than Niti. So if Niti is doing just writing, let's say 100 pages in 2 hours, Navya will write it in 1 hour because she is twice efficient than Niti. Yes or no? Yes or no?
Yes.
Okay, she is doing the work quickly. She is twice efficient than Niti. If Niti is taking 2 hours, Navya will take half of the time. Are you understanding it? That's the meaning of twice efficient. Or you can understand it this way. Let me give you another example. Suppose in 1 hour, Niti can bake 20 cakes. Then thus in the same 1 hour, Navya will be able to bake 40 cakes. Is it making sense? Twice efficient. Neha, are you getting it?
Yes,
Are you
ma'am.
getting it, Neha?
Yes, ma'am.
If Niti can bake 20 cakes in 1 hour, Navya will be able to bake twice of that. That means 40 cakes she can bake in 1 hour. That's the meaning of that. That's what is written over here, that Navya is twice efficient as Niti. Clear? So to cover a task, if Navya is taking X hour, Niti will take double time of that. Do you know that? Because she is very slow. Are you getting it? Yes, Neha and Manvi, is it making sense?
Yes.
Okay, here Niti is slow. So the person who is slow, one day you will wake up and you will go to school. And that day you are feeling so lazy, okay, you so sleepy, and you are just going very slow, very slow, very slow. So you will be taking more time, yes or no? And you will end up just reaching the school and you will say, today I am very less efficient. That means you have taken double the time. Is it making sense? Yes, Manvi and Neha, are you understanding?
Yes.
Yes.
Okay, so Navya is twice as efficient as Niti. That means if a task, any task, a single task is done by Navya in X hour, the Niti is taking 2 times, okay, X for completing the same task. Suppose teacher has given to complete 10 pages. Navya is doing it in X hour. Niti will end up taking 2X hour. If they take 10 days to finish a certain job together they are doing it in 10. Okay. 10 days. How much time will they take individually to finish the same job? Just a second. Together they are taking 10 days. That means the in 1 hour in 1 hour, Navya is covering 1 by x part of the job. Yes or no? Yes or no?
Yes, ma'am.
If Manvi, are you getting it? If I am saying in 1 hour, Navya will do 1 by x part of the work, is it making sense?
Yes, ma'am.
Neha, are you getting it?
Yes, ma'am.
Okay. So in one, okay, in 1 hour, she is doing 1 by x part of the work, and in 1 hour, Niti is doing 1 by 2x part of the work. Both are working together. So in 1 hour now, this much part of the work is getting done. Yes or no? Right? Suppose your efficiency is to cover 1/8 part of the work in 1 hour. Okay. Neha is doing 1/12 part of the work in 1 hour. So both collaborated. That means in 1 hour, 1/8 and 1/12, this much part will get done just in 1 hour. Yes or no? Yes or no? Are you understanding it, Neha?
Yes, ma'am.
Okay. If they take 10 days to finish a certain job, so the complete task is getting done, the one whole task is getting done in 10 days. That means in 1 day, wait, I have taken hour, I must take day over here. If the complete task is getting done in 10 days, that means in 1 day they are doing 1/10 of the job. Yes or no? Think about it. On the first day you did 1 by 10th part. Second day you did 1 by 10th part. Third day you did 1 by 10th. Fourth day you did 1 by 10th. And this is how you will continuously work for 10 days. Then only the work will get completed, right? The whole work will be done. Yes or no?
Yes.
Making